Um, Welcome everyone to the 2020 World Youth Conference for Climate Change. My name is Luke Zhao, and I'm one of the founding members and organizers, along with Edmond Yu and the rest of the Climate Change Task Force for today's event. I want to first say a huge thank you to everyone who could make it to our event. I know we have several guests from across the world, and we understand how late it could be or how tired you must feel after, say, a long day of working. But nevertheless, you've shown your dedication to helping our world and to providing a helping hand to saving our environment. And we truly appreciate and look up to that sentiment and drive. Now, who are we? We are the Climate Change Task Force, a fairly new group of middle school and high school volunteers founded about a year ago with the sole purpose of trying to fight climate change and to make a difference in the world, whether it be coming up with new ways to spread awareness about the current state of the world's environment or increasing recognition about the various climate change curriculums out there. Um, Now, the purpose of the 2020 World Youth Conference for Climate Change is to hear from different individuals and experts about the current state of our environment and where the Earth is as of right now. So on the screen here is our prospective schedule. Take a look at it for a second. As you can see, uh, first will be our guest keynote speaker, Dr. Ian Fenty, followed by a question and answer session for all of you guys to ask him whatever questions you might have for him. Following that will be Liam Feng talking about the widespread causes of climate change, as well as several key points about carbon emissions. Finally, Edmond Yu will present his talk on the combination, and I will be following Liam Feng, discussing the devastating effects of climate change, as well as several key points about carbon emissions. And finally, Edmond Yu will present his talk on the combination of the climate change curriculum with community service, and in paying that forward doubly. So in between each of those last three presentations by members of the Climate Change Task Force, there will be around 10 minutes or so of discussion time, varying depending on demand, for any of you guys to bring up any topics you would like to discuss with our group here. So these periods of discussion are also points in time for any of you guys to take a short break and to relax a bit, but we strongly encourage you guys to engage in this discussion with the other attendees of the conference. So again, feel free to take a picture of the schedule or to jot this down somewhere if you would like. All right, let's go on. So as I'm about to wrap up my part here, I wanted to say that it is my pleasure to introduce today's keynote speaker, Dr. Ian Fenty. So here's a little introduction about him. So Dr. Ian Fenty is a climate scientist from the Jet Propulsion Laboratory in Pasadena, California, who received his PhD in climate physics and chemistry from MIT. So having researched a number of extremely intriguing topics, including, in my opinion, the most intriguing being the variability of the coupled ice atmosphere ocean system, this connectivity, and having quantified various observational models, Dr. Ian Fenty is clearly an expert on the climate of the Earth. And today he will be discussing his work and his experiences with us. So if you have any questions for him, please leave them in the chat or save them for the Q&A session afterwards. So Dr. Ian Fenty, if you are there, please take it away.
Hi. Well, welcome everybody, and thank you very much for inviting me to speak to your group. Very happy today to talk about a topic that's very important to us climate scientists right now, and that is the topic of sea level rise. So I'm now going to share my screen. And can you see the screen? Does it look okay? Yes.
Yep,
Okay,
looks
great.
good.
Great. So I will talk about sea level rise, which for climate scientists is a topic which is very important because it is something that captures a lot of the signal of climate change. So today we'll talk a little bit about the causes of sea level rise, how we know sea level rise is happening, and what we think will happen on this topic in the future. There was a little introduction about me, but just to make this a little bit more informal, just thought I'd show you what I look like. Right now I'm in my kitten condo. He's very cute. I got interested in climate change when I was a youth in high school and middle school in that time frame. I was very fortunate to be able to pursue a doctorate in this topic at MIT when I was after a few years of working in the business world. And there's so much to study and learn about with climate change that I was able to continue my education, so to speak. And I think I would say it continues even today, working as a climate scientist at the NASA Jet Propulsion Laboratory in Pasadena. So sea level rise, why should we care? How we observe it from space, how we know that global warming is driving sea level rise, and what are some of the projections? So why do we care about sea level rise? Sea level rise is going to be extremely costly and painful and difficult and expensive for millions of people around the whole world. And this graphic from a relatively recent paper, I think, really uh, describes to me the widespread impact of climate change and sea level rise on vulnerable populations. So what these authors did was they looked at different coastal cities around the world and saw and made a projection how much the people in those cities will be affected by sea level rise. And interestingly, not all of the people who are affected are in, let's say, poorer or less developed countries or only low-lying countries. Like people often talk about Bangladesh, for example, as a place that's particularly vulnerable. But there are 3 of the cities around the world that are in the US. And the reason that is interesting to me is it says that even in a country like the US with the resources that all the resources that we have, when cities like Miami, New Orleans, and Tampa St. Petersburg area become flooded, as scientists think they will, we as a nation won't have the resources required to respond to the displacement of all of those millions of people. So if in the US we can't do it, imagine how much worse it is going to be for some populations in other countries that aren't as wealthy. Uh, Something that people often also don't think about is that sea level rise won't start doesn't you don't have to wait until your house is completely flooded for sea level rise to affect you. As sea levels slowly rise, flooding will happen more and more frequently for people and populations and agricultural lands, making them uninhabitable far before they become permanently flooded. So sea level rise is not a distant threat of climate change. It's a very real and present and serious threat that's basically at our doorstep today. So how do we know sea level rise is happening? NASA and other NASA, along with other U.S. agencies and other countries, observe the Earth from space. And this is a schematic showing a cartoon showing all of the different instruments, satellites that are flying and observing Earth today. Some of these satellites are called satellite altimeters. And a satellite altimeter has been flying around, at least one has been flying around the Earth since the year, um, the first one, excuse me, that was ever flown happened in the year I was born in 1978. And since 1992, we've had a continuous record of, sea levels from space from this series of satellites that you see on the right-hand side. So how does a satellite altimeter work? A satellite altimeter flies around the planet in an orbit, and it sends down frequently sends down radar pulses towards the Earth, and when it does so, it starts the clock. The radar pulse travels from the satellite to the sea surface and then bounces back to the satellite. And then once the pulse comes back, we stop the clock. And because we know how fast that radar pulse travels, which is essentially the speed of light, we can easily calculate how far the sea surface is from the satellite, and then we can figure out where the sea surface height is by subtracting the distance from the orbit to the sea surface from the satellite orbit. So because we measure the sea surface height continually from space for almost 30 years, scientists have been able to make very careful maps and measurements of how the sea surface height has changed around the world. And when the good news also is that we have data even from before the satellite era. Before satellites, sea levels were regularly measured by tide gauges at commercial ports around the planet. And many of these tide gauges were recorded carefully in logbooks. Scientists have gone back and digitized those logbooks and put those information together with our understanding of the patterns of sea level rise and come up with a map like this, which shows that sea levels have risen about 9 inches in the last little bit more than a century. So from this figure that shows a steady increase of sea level rise, there's something which is really striking, and that is the rate of sea level rise is increasing through time. In the early 19th century, sea levels were rising very slowly at 2/100th inches per year, and now they're rising more than 6 times faster. And this acceleration of sea level rise is something that really has many scientists concerned, because the acceleration of sea level rise far exceeds what people predicted it would be even a few decades ago. Uh, Sea level rise varies significantly around the world. The Earth ocean is not just a bathtub where if you put in more water, the bathtub level rises everywhere equally. Because the climate is like a very dynamic system, many factors affect exactly what sea level rise is in any one particular place. The average today is a little bit more than 3 millimeters per year. That's the light orange color. But you see there are many places where sea level rise has been faster and places where it's been slower. One place where you notice it's been slower than average is on the entire west coast of North America and South America. And that's because as the climate changes, winds also change. And the changing winds have helped to push water out of this sector of the ocean into other sectors of the ocean. So sea levels have been rising, but not equally. Over a long time period, sea level rise will be, approximately equal everywhere. And therefore, we can expect that on the US West Coast and the South American West Coast, sea level rises will probably accelerate a lot faster in the coming decades. So this is very interesting because another thing that's very interesting about this is that you can see that not only are is the are different parts of the U.S. coast uh, affected by sea level rise differently today, but that some places, for example, in East Asia and South Asia, they've experienced higher than average sea level rise already. So how do we know sea level rise is related to global warming? Well, this is a global warming conference. Many of you are educated already about basic ideas of climate change and global warming. As scientists, these are some of the charts that we talk about and we use all the time in our work. The top left one is the very important record of atmospheric carbon dioxide made from pristine air in an observatory in Hawaii since the late 1950s. And you can see a steady increase of carbon dioxide every year since the record began. Also, you can see a curvature in that plot. Carbon dioxide levels are rising 3 times as fast today as they were in the 1960s. We know that global mean temperatures have increased. We know that um, uh, that the warming has been unequal, and we know that the warming has increased overall on the entire planet. So all of these charts show one thing, that the climate as a whole has been warming. But how does that connect to sea level rise? Well, one of the biggest factors of the increase of sea level rise has been the increased melting of Earth's ice sheets. And by ice sheets, I mean specifically the Greenland and Antarctic ice sheets. Together, Uh, these ice sheets have lost uh, about 6,000 gigatons of ice over the last decade and a half. And a lot of the uh, melting has happened at the lower elevation coastal regions where the glaciers and the ice sheets come into direct contact with the oceans. We know from other work that both the atmosphere and the oceans are warming, and that ocean warming helps to explain why the ice sheets are melting where they have been. In Antarctica, you see some blue on this graph. That blue means that there's actually more ice in those sectors. This is one of the predicted outcomes of global warming. As the atmosphere warms up, there tends to be more moisture, and in some places, there can be more snowfall. So in this East Antarctic sector on the top of that figure, there has been actually an increase of snowfall, which takes water, of course, out of the ocean. But if you add it all together, the loss of ice in West Antarctica, where it's dark red, far exceeds the amount of new snow that's fallen in East Antarctica. So overall, Antarctica has been losing mass. And you can maybe also tell from that chart of Antarctica that the rate of ice mass loss has been accelerating over time. In fact, the melting of the Greenland and Antarctic ice sheets has been one of the real surprises in climate science. The rate at which they're melting is much faster than scientists predicted they would be. They would. As I mentioned, both the atmosphere and the ocean are warming, and we can actually quantify how much of sea level rise comes from melting ice and from uh, warming oceans. Now, the idea behind sea level rise from warming oceans is that seawater, like many materials, it actually expands when it warms up. But because the oceans are surrounded by continents, when the water expands, it can't expand out, it expands up. So as the oceans warm up, the sea levels rise. And about 40% of all of sea level rise right now is due to the warming oceans. Now, the other 60% of sea level rise is about equally split between the melting of the polar ice sheets, Greenland and Antarctica, and the melting of mountain glaciers like the Himalayas, the Alps, Patagonia, glaciers in Canada and Alaska. In the future, we really don't know how much more melting of the ice sheets and the mountain glaciers is going to happen. Of course, there's a lot more ice left in the ice sheets to melt, and the mountain glaciers are shrinking so quickly that in the next century or two, they'll all have completely disappeared. But in the next century or so, we don't know exactly how fast either one of those two things, either one of the sources of ice will melt. And a lot of climate scientists, especially many people I work with, are focusing on that part of the problem because it's the source of the greatest uncertainty. So let's talk about the uncertainty of global warming and climate change a little bit. This is something that I'm sure that many of you participants of this talk and in the organization think about, and have seen something very similar to this. So I'll just try to walk you through this very, give a little bit of time for it because it is important. So scientists, we don't know the future. We don't know exactly how fast climate will change, but we still need to have a common language to talk about different ways, different projections that we have. We all just can't make up our own projections based on our own different ideas about what the future will look like. So what we've done is we have decided on a group of scenarios, and those scenarios represent different future emissions of greenhouse gases. So in the red curve, the left-hand side shows how much CO2 we expect to be in the atmosphere as the y-axis. On the x-axis is through time. So in the red scenario, the so-called RCP 8.5 scenario, humanity does not do anything to decrease greenhouse gas emissions. In fact, we do the opposite. We do everything we can to increase greenhouse gas emissions through the building of, for example, many new coal power plants. And in the RCP 8.5 scenario, greenhouse gases concentrations in the atmosphere increase from where they are today, which is about 414 parts per million, up to 1,200 parts per million. And then the opposite kind of extreme of that, we have the RCP 2.6 scenario. And the RPC 2.6 scenario is a future in which humanity has a major reduction in greenhouse gases, and we stabilize greenhouse gases in the atmosphere at a level of about 450 parts per million. And then through natural processes, the Earth is able to reduce the amount of carbon dioxide in the atmosphere down to about 400 parts per million. You'll see 400 parts per million is still considerably above where they started in pre-industrial time periods. But we think in that scenario, we can keep global warming below 2 degrees Celsius. And then, of course, in between, we have many variations of intermediate scenarios where we do we do better than 8.5, but not as good as 2.6. And the amount of global warming and sea level rise can vary considerably between those scenarios. So that's what the scenarios are. Just remember, 8.5 is the absolute worst case, and 2.6 is an incredibly aggressive worldwide policy that starts yesterday on changing how we do greenhouse gas emissions. So I'm going to focus on different projections of global warming from RCP 8.5 and 2.6 because those are good end members. So what is the projected global warming at the end of the century in those two scenarios? On the left is the 2.6 scenario where, like I said, it strives to keep emissions to below 2 degrees Celsius. And you see on this map that indeed, globally, the projected temperatures are on average below 2 degrees. 2 degrees Celsius, which is, and then on the other extreme, the RCP 8.5 scenario, where we have very high greenhouse gases, temperatures around the planet are, I see my graph here for the Fahrenheit is off by a factor of 2. I'm sorry about that. No, more than that. Should be 9/5 times Celsius, not 5/9 times Celsius. I'm sorry, I made that last night. In case everyone wasn't familiar with Celsius, but then I screwed it up because I only work in Celsius. Right, so the 8.5 scenario looks nightmarish. I think the scientists who made this plot, intentionally picked very dark and scary and fire-like colors to convey that a future of RCP 8.5 would be really terrible and have widespread negative effects of global warming around the entire planet. So those are the warming, but what is the sea level rise? So an equivalent for sea level rise, interestingly, even the RCP 2.6 scenario has sea level rise that's above 0 everywhere. And in fact, if you look, it's about 1/2 meter on average everywhere. And the reason for that is as the planet warms up to 2 degrees, the Greenland and Antarctic ice sheets will keep melting. The mountain glaciers will keep disappearing, and the ocean will keep warming up. So even at 2 degrees Celsius, sea level rise is going to be with us for centuries. And that's why we have to be prepared for sea level rise, make plans for sea level rise now. Of course, it could be much worse than this 1/2 meter in RCP 2.6. In the RCP 8.5 scenario, we think that sea levels could be 1 meter or more higher on average. And that meter or more doesn't even take into account a possible catastrophic loss of some parts of the Antarctic ice sheet, which some scientists think is possible. So these are kind of trying to give you a sense of what different futures look like for us. The one on the left is almost guaranteed as a minimum. The one on the right is not at all an impossible situation. The reality is, if I had to make a bet, it would be somewhere in between these two, which still is a very serious amount of sea level rise for populations around the whole planet. So now the question is, what can we do about this? And I work as a scientist. I collect data. I do analyses. I run climate models. Uh, I'm not someone who works in policy, so all I can do is report to you what some of the like the scientific argument for it. I can't say how we should make the changes, but these are the changes that need to be made. So according to the IPCC, the only way that we can limit the risk of climate change is to substantially and in a sustained manner reduce our greenhouse gas emissions. Now, greenhouse gas emissions are not just from carbon dioxide, of course. Methane, carbon monoxide, nitrous oxide, and other gases all contribute to global warming, but carbon dioxide is the single largest source. And you can see on the right, bottom right panel, where our emissions come from. And you can see a great amount of our emissions come from transportation, industry, electricity and heat production, areas where technological innovations could be made to reduce the carbon footprint of those sectors. And these are areas in which technological improvements are, let's say, desperately needed. Some, like electricity, those we already have solutions for. We already have technologies to replace a great amount of electricity production around the planet. We just have not yet implemented those fixes for economic and current political reasons. Uh, and then here I will talk a little bit. People always ask what it is that they can do themselves to meet the challenge of of global warming to reduce their greenhouse gas emissions. And this is by no means an exhaustive list, and it's something I'm sure you guys will talk about through the rest of your meeting. And these are in no particular order, but this is really my opinion. The number one thing the most important thing in my mind that you guys can do is civic engagement, because the challenge of global warming is bigger than any one of us. The way that we solve this problem is by organizing ourselves as communities. That means uh, uh, conferences like this, organizations like the ones you have made, talking with your uh, classmates wherever you are, or your coworkers wherever you are, and get them organized. In a place like the U.S., that means we have the freedom to march, to protest, to make voices heard about what topics are important to us. The higher we can make climate change, the higher profile we can make it as an issue that's important to us, the more our politicians will have to respond to it. And of course, if you are of age, voting is one of the most important things you can do. Voting for politicians and parties that accept the reality of global warming and have good plans for doing something about it at different levels of society. Number two thing is promoting climate literacy, and you all are doing that today by coming out to learn more about climate science and climate change. There's a lot to learn. I've spent the last decade and a half as a student of climate change and working as a scientist in climate change. And I can report that I learn something new about this subject almost every single day. But the basics of climate change, I think, are still not really understood by most people in our communities. So it's very important that we do everything we can to communicate the basics of climate change to people in our home and in our communities. And only when our neighbors and families understand the basics of climate science will they feel motivated to do the first thing, for them to vote and to be engaged and to make it an issue that they care about. Okay, the number three thing is everyone should educate themselves about their own carbon footprint. You know, if you just watch TV and watch, sitcoms, or watch, TV and that show people and their lifestyles, you know that most people that you see on TV live lifestyles that are far wealthier and more excessive in carbon than most normal people. But even us, even like people like myself who live in the U.S., who live in a city like Pasadena, we have a carbon footprint that's much larger than people in most countries around the planet. So it's really important that we understand ourselves what our contribution to carbon, to greenhouse gas emissions, are. And there are many websites you can visit. I'm not going to recommend any one because they all have a little bit different way of doing the calculation. And the idea is to get a general sense quantitatively, but you don't have to get it to the exact, 8 decimal places. But everyone should just go and spend like half an hour and calculate their own carbon footprint and see what they can do in their own lives, and maybe convince their parents what they can do in their life to reduce that a little bit. If everyone worked to reduce their carbon footprint, then we could make a big difference, especially since in the US we have such a large per capita greenhouse gas emissions. One of the simplest things, like the most personal things you can do, that's really the simplest thing you can do, is just eat less meat. And there's a chart here I think is very good, that shows on the top, it says average diet, and that's in the equivalent of carbon dioxide, kilograms emissions per year, per person per year. So the average US diet is about more than 2,000 kilograms of carbon dioxide equivalent per person per year. And if you look on the very bottom of that, a fully plant-based diet is just a small fraction. It's just, it's almost a 90% reduction in the greenhouse gas emissions from what you eat. And especially if you live in a country like the US, if you live in a city like Los Angeles or live in Southern California, having a plant-based diet has like never been easier, and it's just something that you can do to make a big impact on the climate. I'm not talking about health benefits of a plant-based diet, although I hear that there are many, but strictly from a greenhouse gas emission point of view, it is the simplest thing you can do. And you can do it one day a week, you can do it one meal a day, you can do it however you want, but uh, the closer you are to plant-based, the bigger the impact will be. And of course, we have to, on a larger level, we have to reduce our collective use of fossil fuels. In places where it's sunny all the time, we can use solar power. And of course, as a nation, we should adopt a larger fraction of our total energy production from renewable energy sources, including both wind and solar and others. And of course, you know, people often ask me, how do I stay positive about climate change and climate science when every day we have to face like professionally how bad things are for the planet? And I think the answer is just to keep a positive attitude about, to believe that you can make a difference and that what you're doing is making a difference. A positive attitude is really a great antidote to feeling despair about climate, which I know a lot of people face, because things, if you read the papers and read the studies, things do look very bad. So, but, you know, RCP 2.6 is something that we can do collectively. It just requires everyone to stay positive and to act in a coordinated way. And if we did that, then we can reduce the uh, big negative impacts of climate change. And my last slide is something that's kind of cool. It's related to the topic, but this is something that's, it's not about sea level rise per se. I mentioned before that NASA has been measuring sea level rise from space continually since 1992. Well, the next satellite in the series of satellites that will measure sea level rise from space is going to be launching in a little bit less than 1 month here in Southern California in a place called Vandenberg Air Force Base, which is just north of Santa Barbara. And anyone can go to the area on the day of the launch of this satellite and see it take off. And we're very excited that this one will launch on a SpaceX rocket. I went to Vandenberg to see a launch of one of the satellites that measures the melting of the ice sheets that I showed a figure of before a few years back. And like I said, you can't get onto Vandenberg Air Force Base. It's a closed property, but there are many neighborhoods and streets around where you can park, and people go and bring their binoculars and bring lawn chairs and bring coolers, and they hang out. This is going to be 11:45 in the morning, which is perfect because the usually it's good weather. 11:45, clear skies. So if you have a chance, you know, you don't need to go to work that day or don't need to go to school that day, or heck, I would call out sick, or I would play hooky that day myself. I'm going to go spend the day and see the next one of these satellites launch into space. It's something that you'll never forget. So that's the end of my science talk, and I guess now I'll be around to take some questions if there are any.
Dr. Fenty, I actually have a question for you. I believe you mentioned in one of your slides that the IPCC said that we must lower global emissions as a way of addressing climate change. Like in my recent research on climate change, I found that the IPCC actually almost always underestimates the effects humans have on global warming. So my question to you is, can you give us some insight on the depth and the how hard it is to truly research about the topic of climate change and make that research as accurate as possible?
Well, the question you ask it's a very deep one. It's a very good question and very deep. So the nature of the IPCC reports is that they are consensus documents. And let's think about what that means. Say you, me, and Luke, and we're all in a room, and we had to make a prediction about what the temperature would be in 100 years from now. If I said it was going to be 10 degrees warmer, and Luke said 5 degrees warmer, and you said 2 degrees warmer, well, we all don't agree, right? But we all agree on 2. We agree at least 2. So the IPCC report, in effect, reports on the 2. It reports on the numbers that everyone can at least agree on. Some people, like in this example, think it'll be much worse. Some people think it'll be medium worse, but everyone can agree on the 2. And that's the nature of how this document comes into being. And you can see the problem with this, right? Well, there's a pro and a con. The pro is that everything that's in that document is something that everyone has agreed on, right? which means the document itself has a very solid foundation. And as I've served on a couple of review panels of ICC pieces of IPCC reports, and I can tell you, people sit in a room and they debate, how individual sentences are written so that they capture a consensus sentiment. Like every sentence is scrutinized in it. That's the pro. It's you can trust that all of the scientific statements that are in there are ones that everyone can agree on. But of course, the con is that it's a minimum, right? It only predicts the minimum. It reports on the minimum projections, the minimum what people think. And there are scientists, some of whom I work with, who think that uh, it really underestimates what the future will look like with, in particular, about sea level rise. But you know, those scientists are not. They don't have crystal balls either. That's their professional opinion, and it's a minority. So, it's not a problem as a scientist to do work and make one's own predictions. It's not like there's any forces that prevent us from doing that. Or at least at least where I work with NASA, people can pursue their science and honestly and with integrity. The challenge is, how do you communicate to the wider population and decision makers what the real risks are, right? As an individual, one doesn't have very much. One isn't really speaking from a position of much strength. That's why the IPCC report is kind of there, right? So, and that's not a complete answer to your question, but that's kind of like part of the pros and cons of how the IPCC report is written.
Thank you for your answer. I actually see someone who has raised their hand in the participants list. So, if you want, you can unmute and ask the question.
Yes, hi. Thank you for telling us these interesting things. Do you think we have the technology to reach the 1.5 or 2 degree mark? Because often politicians said, whereas we can't do, we haven't a chance. And do you think we have enough technology, and it's only the courage which we need to change our style?
Yeah, thank you for the question. Well, if I see here correctly, you might be calling from Germany. And, Germany is one of those places that delights me as an example, in particular because of the policies of solar panels. One doesn't necessarily think of Germany as a place that's sunny all the time, right? North Germany in the winter can be a pretty cloudy place. And yet the country has made great progress in transitioning to renewable energy through policies and technologies that are available today. So I think the answer is yes. Today uh, we could transition a great fraction of some of these sectors. We could reduce the carbon emissions associated with them. For electricity, there are countless people who work, and all they do is say, if you put windmills here, and here, and batteries here, and this part solar panels, then this country can be electrified. If you use this other form of technology, this country can be electrified. So we know today that it can be done for many countries. What is missing in those countries is in my opinion, simply the political and collective will to do so. There are many like political pressures to keep certain greenhouse gas burning technologies and industries going. And also, it can be more expensive in some places to use renewable energy. So collectively, I don't think we can just rely on the free market to get us to a renewable energy future. We need to accept that it will be more costly in the short term to transition, but in the long term, we will all benefit from doing so. Of course, just as a, but it also must be said, technologies are getting better, right? Solar panels are much cheaper today than they were 10, 20, 30, 40 years ago. So the technologies are there. They are getting cheaper and cheaper and cheaper. We really cannot afford to wait any longer, and we don't need to wait. The only argument people want to make to wait is that it might be cheaper later, but that's just a guess. And we know every year that we wait, it's going to get more, the costs of climate change are going to get higher.
Could I ask one question? My name is Lovra, and I want to ask about ozone holes. I don't think that that is mentioned in this presentation. From the past informations, I think that the ozone hole that is like above Antarctica was closed, as I heard, but there's one above the North Pole. Is this a very serious issue, or is there any way to fix the ozone problem?
Well, the ozone problem is one that is people usually talk about as a great success. When scientists learned that chlorofluorocarbons participated in a chemical reaction that destroyed stratospheric ozone, they were able to convince policymakers around the world to reduce the amount of product that used CFCs. And as a consequence, the ozone holes at the poles, at both poles, were able to start to, let's say, heal. One CFC molecule can participate thousands and thousands of times in a chemical reaction which destroys ozone. And they live in those CFCs, can spend a long time in the stratosphere. So it took decades for CFC levels in the stratosphere to reduce, and for the ozone levels to return to a state that let's say of a normal state. So it's a very long and slow process, and I don't think either pole has completely recovered, but they have recovered much more. They have recovered a lot, and the state of the ozone hole is just much, much better now than it was, and so much better than it would have been had we not, as a global community, transitioned away from using CFCs. CFCs are not banned everywhere. There are still some CFCs being produced. There are some nations that don't care, but overall, it's something that people talk about as a success story. And the reason, okay, as a corollary, some people think that this was a success is because we had an alternative to CFCs that weren't that expensive. So it was relatively not that painful for society to swap out the dangerous CFCs for something that was less bad. With greenhouse gases, the problem is much harder because fossil fuels, it's not so simple to just transition away as it was with this one chemical that was used in just a relatively small number of industrial products. But it's a good topic. It was one of the first topics of environmental change that I ever learned about, and it's a great, if you're interested, I highly recommend that you learn about the politics and the policies around that time to learn about what worked and how the Montreal Protocol came into effect and how it's been enforced over the years and how scientists still study it, still monitor the ozone hole to make sure that it is healing the way that we hoped it would.
Okay, thank you.
So we have a question from Daniel in the chat. Daniel saying, I hear manufacturing of solar panels causes a lot of pollution. Do you think it will negatively impact the local climate where they are produced, even though solar panels help reduce greenhouse gas emissions in the place they were or are widely used?
Yeah, that's a great question. There's virtually no production that can take place that doesn't have a negative impact on local environments. I just think we need to look at that like straight in the eye, right? We can't pretend it's not happening. What we have to do is realize that the alternative is much worse. Having a world where we just burn natural gas, oil, and coal, and deforest and burn other fossil fuels is a future that's much worse than one in which we have to despoil a few pristine locations to extract valuable rare earth minerals and certain elements from the ground. And I think that we probably should do everything we can to help the local populations in those areas that are going to be affected by increased production of solar panels and batteries, because that's really what people are talking about. It's an argument, I think, for looking at a whole portfolio of different renewable resources. I don't think we can have just solar panels or batteries. Wind is a lot. I think the impact of the local environmental impact of producing a wind turbine is much lower. Is lower, right, in some sense. So that's why we should have a mix. But yeah, for many of the technologies that are required in the future, there will be a cost. We need to be honest about it. We need to be able to look at that in context of what the costs are today and make informed decisions.
So I just have a couple straightforward questions. So number one, for those RCP graphs that you showed in your slides, where'd you get the numbers and the graphs for those?
Oh, these these I took from one of the recent IPCC reports. So if you guys don't know about these reports, if you have never seen them, I highly recommend that you find the latest reports. They're available online, super easy to find. And the best part about them is they break the reports into kind of different levels. So they have the highest level they call executive summary for policymakers, which is just fantastic because they assume that people who are reading that don't have the time to learn about the science. They're just, the senator's aides, just someone who just needs to know what is the bottom line. And then they have different reports, different versions of the report that at the most granular level are basically scientific review papers. And they have extensive citations. They're written and reviewed by scientists, and they just serve as a fantastic gateway to learning more about the science. And it's usually written in pretty clear language. It's somewhat technical at times, but not nearly as technical as the original scientific journal article. And they have great figures. Yeah, I just highly recommend it. And then another part of those reports is that they'll have the scientific basis, scientific part of it, and then they'll have the kind of the policy or the more like the social science part of it, where they'll also talk about what the projected impacts are on people and populations and communities around the world. So taken together, these are just such an incredible resource that we all have access to. the major reports come out every 4 years or so, and then in between the major reports, they'll put out these kind of special focused reports. I could talk about how much I love these things all day. They are just fantastic resources. And like I said, a great place to get started. Right before I started my PhD, I thought I want to study climate science, work on this area for the rest of my career. And what did I do is I went and I found the IPCC reports at the time, and I studied them just to get a big picture idea about what the state of the science was. So you'll find it. You can see it's on the bottom here. This is the synthesis report from the 2014 version.
All right, cool. And my second question is, how can you calculate your own carbon footprint?
Well, like I said, there are different groups that try to come up with like they're basically calculators for it. So they'll say, okay, where do you live, and how do you heat your house, right? So and how many people live in your house? So they'll say, okay, well, if you live in Hawaii, you don't heat your house. So the amount of oil that you burn to heat your house is 0. If you live in Sweden, they know that you probably live in a house that has natural gas, and they know the temperatures, and they'll say, okay, well, probably, and they know what kind of furnace you have or heat pump you have, and they'll say, okay, probably this many kilograms of fossil fuels are used to heat your house. And then how many people do you live in the house divided by that, and a couple factors that turn that into greenhouse gas equivalent. So these websites, they ask you questions like that: where do you live, and how many miles a year do you drive, and what kind of car do you drive, and what do you eat, and how often do you buy new clothes, so on. How many Nintendos do you have? They'll ask questions like that, and at the end, it tries to come up with a number of what your contribution is to carbon emissions, greenhouse gas emissions. Yeah, and like I said, there's not like one way of doing it, because they have to make a lot of assumptions. They don't know exactly what Luke Zhao's house looks like, but they can make a representative guess from like your zip code. So that's why I say there's no one way of doing it. You should try a couple different ones, different websites. And if you are interested in the actual procedure, the good ones will be transparent about it, but it's an area that you certainly can learn more about from like a technical point of view. Yeah.
Okay, so now that we have summed up the Q&A session with Dr. Ian Fenty, we'll move on to more of the student speakers and with topics regarding the effects and causes of climate change. So here is Liam with his first speech.
Give me 1 second, everyone. I am getting it ready. Here we are. Can everyone see my presentation all right?
Yeah, we can see it.
Nice. Okay. So, first of all, a humongous round of applause for Ian Fenty. That was fantastic. That was absolutely amazing. Incredibly inspirational. And then, hi everyone, I'm Liam Feng. I'll be your first speaker, and as well as the person who has the wonderful opportunity to present to you the first topic, which is going to be the causes and effects of climate change. And I wanted to take advantage of this wonderful, fantastic opportunity and hone down on a much more specific cause that I am incredibly passionate about. And I feel incredibly lucky to be the one to introduce to you all the causes and effects of livestock pollution. So to begin, I want to paint a picture of what this industry of livestock really looks like. And for those of you who don't recognize the person in this picture right now on the slide, this is Sister Dorothy May Stang. And she was an American nun and environmentalist. She worked for the Pastoral Land Commission, which is a land commission in Brazil. She was she is a non-violent deforestation activist. She speaks so much about the Brazilian land mistreatment, all the way from illegal land plunderers, loggers, farmers, ranchers, and she spoke out against all sorts of sources of illegal land exploitation. And the work and dedication Sister Dorothy May Stang put in laid the groundwork for humongous major Brazilian policy changes. And it was from Sister Dorothy Stang that in 2005, the world had received a warning. And this warning didn't come in the form of a groundbreaking article or an incredibly inspirational speech. This warning came in the form of a fatal wound, a gunshot wound that left her body found in Pará when she was at the age of 73. And the cause for this terrible murder was from a Brazilian rancher who, unsurprisingly, like many other ranchers across the world, attacked environmentalists for their disruption of their agriculture industry. And Dorothy May Stang was a warning, but she was only one of many, many environmentalists across the world. You probably heard of these ones: Chico Mendes, Nazildo de Santo Brito, and Maxiel Pereira de Santos. They are all defenders of deforestation, anti-palm oil, Brazil's indigenous people, and they have all suffered terribly from the industries. And the NGO Global News Witness reports estimated about 3 environmental activists have been killed every week. And a humongous contributor of this statistic comes from this corporate entity of the agriculture industry. Now, a question you might be asking is, why would they be doing this? What is this really necessary for them to do? Well, it would be because the agriculture industry, specifically meat production, is always under attack, is consistently under attack by environmentalists around the globe because of the damage they do to our planet. These are the true costs of the livestock industry. Growing livestock takes up about 1/3 of all the world's fresh water. It occupies 45% of the Earth's land. The land it takes to grow and feed livestock makes it the cause for 91% of Amazon deforestation. In other words, the livestock industry is the #1 cause of deforestation in the world. Well, meat products that are created from the agriculture industry, they are also incredibly water intensive, where on average, in proportion to the amount of water a single cow needs to drink, if you were to divide that by the amount of burgers you can actually make from a cow, it takes over 660 gallons of water just to produce one hamburger. And that is an incredible amount, especially for the common person, where if they want to do their part in saving the planet, they might consider doing things like showering less, or bathing less, or washing their clothes with more natural means. But the amount of water it would take to produce one hamburger is equal to the amount of water it takes to fill 50 bathtubs or to take 135 showers, which is an incredible amount, just speaking for one burger to be produced. This industry is also the #1 contributor to human-caused climate change. The cows alone, just talking about cows for the meat industry alone, for America, are responsible for the production of more greenhouse gases than all the world's transportation sector combined. Along with 500 million tons of manure is produced per year, 3 times as much as we humans do. And this is just talking about cows, these livestock animals that we are raising for food consumption. As you can see from this picture, for all the vehicles in the transportation sector combined do not amount up to the amount simple cattle can produce from greenhouse gas emissions. From Ian Fenty's presentation, we saw from one of the slides that 65% of all greenhouse gas emissions come from CO2 production. 16% come from methane, a very potent greenhouse gas that is up to 28 times more powerful than CO2. So if CO2, if carbon dioxide, if they come from things like cars and vehicles and ships and airplanes, then what's responsible for the production of the methane? A huge contributor to that would be cows. They're humongous methane producers, and processing the meat for the livestock industry takes up a humongous amount of carbon dioxide as well. On average, 3.6 kilograms of carbon dioxide is produced per burger. If you were to consider that the average American eats around 3 burgers per week, this would mean up to 108 kilograms on average of carbon dioxide is produced just simply from eating burgers alone, which is the equivalent of driving 27 miles in your average car. And all this adds up to the presence, the overall presence of the meat industry, along with the habits and methods of its agriculture. This introduces a fundamental problem to environmentalism around the globe. The way this industry conducts its business, along with the things it has done in the past, forces environmental organizations to turn away, whether it's from fear, intimidation, or just an overall sense to avoid trouble. With over 12.73 million metric tons of meat is being produced just last year in 2019 alone, we should be able to tell that this massive grand scale production makes the meat lobby one of the most influential industries in America, along with one of the most powerful forces of pollution on the planet. So in 2014, the meat industry alone just spent over $4 million lobbying Congress. Now, that might not mean much. That might not be super understandable. But in comparison, this amount of money is over twice the amount people have spent advocating for simple gun control. In 2015, it has been exposed by The Atlantic that meat producers have been collaborating with humongously respectable institutions like the US Nutrition Guidelines, and they've been influencing them for decades, where they would collaborate them and advertise themselves through huge institutions like the US Department of Agriculture. Since 1977, efforts to suggest decreasing meat consumption have been repeatedly derailed by meat industries. You will almost never see things like the US Department of Agriculture advertising you to eat less meat. They might keep the meat consumption level the same amount. They might keep the recommendations at this almost the same level, but you will almost never see them actually recommending to you to eat less meat. And this is due to the outer influence of the agriculture industry. So with all this in mind from my presentation, what's the really key takeaway that I plan for you all to walk away with? Well, the point I am trying to make here is to help save the earth, but most importantly, to help save it in the right ways. Of all the incredibly helpful methods that you probably heard of doing, and you probably considered doing in the past, like showering less to save water, you can save gas, lessen pollution, like you can use less heat, or you can start biking or walking to work, you can start planting trees, etc. These are all incredibly helpful methods that all help our planet become a better place in their own specific ways. But what I learned is that they will never amount to the impact that you could make by slightly changing your diet. A huge thing, when I was doing my research, a huge thing that caught my attention, what caught my attention the most was how easy it is to simply make a change for the environment. It doesn't necessarily have to be to saving gas, less pollution, or showering less, because eating a bit less meat now and then will always be one of the biggest impacts you can ever make to save the environment. And with that as my choice of a final message, I choose to end with presentation. I'm open to questions.
We have a question from Ranja, if you can unmute.
Yes, of course. Thank you for the presentation. Actually, I often heard that vegetarians aren't that much better because vegan people are much better, and there isn't a great effect if you eat more, for example, more cheese and less meat. How big is the difference? And how big is the difference if you look at vegan people, or you compare vegan and vegetarian people from the impact it has?
Well, if you're going to be comparing, making this comparison between the average vegan and the average meat eater, a lot of it depends on a huge variety of factors. For example, what part of the world are you considering? What kind of a meat eater? What kind of meat products is this meat eater getting their meat products from? Because the amount of pollution, the carbon footprint, the impacts meat products make on the environment, they have the potential to vary from sources to sources. There are, certain meat industries that can create a better impact than other ones. But overall, I would definitely say that vegans do help the planet, and they do create a much less negative impact on the earth than your average meat eater would. Huge vegan companies like Beyond Meat, Impossible Burger, they are all working incredibly hard to enhance their meat products. But as of right now, their products aren't reaching the widespread popularity they have the potential to become. They're taking in massive amounts of revenue, but if you were to search up the actual amount of profits that your average vegan, like for example, Beyond Meat, I search up Beyond Meat, and what you might find is that the amount of profit they're making is actually incredibly small, because so much is in the development stage of their product that right now they are in the hard moments of really introducing themselves to the world. Right. So the average vegan, I definitely would say from the sources that I've seen that they definitely have a much less of a negative impact on the planet.
Okay, thank you.
Thank you for the question. I actually have a question myself for you. So this is diving into more of your personal experience with this topic. You say that you were extremely passionate about it from the start. So what made you get into this topic?
It started with a documentary I saw from my grade 11 class. It's called Cowspiracy. It's a Netflix documentary, and it's incredibly eye-opening. I highly recommend for those of you who've never watched or never heard of it to watch Cowspiracy or consider listening about it. It's a huge eye-opener for me because it opened up this industry that a lot of the environmental organizations never really properly directly talk about. They never really properly address this. Yet the agriculture industry's effect on the planet is so big. And I thought that was incredibly interesting. And the more research I did on this topic, the more I realized just how much of an impact meat products actually make on the planet. And that led to me being passionate about this topic.
Okay, yeah, thanks for your answer. That's very good insight into how like other people might get into certain topics related to climate change and truly make a change for the world.
Right.
Does someone else have a question?
I have one question. So we mentioned vegans, but I would like to ask about vegetarians. Like, if
Oh,
a person is not eating meat, but it eats like products like cheese or milk, like how much of a big of an impact do these people have on the environment?
if they refuse, if a vegetarian refuses to, if they don't eat meat, but they
But they
consume
eat
dairy products,
like cheese
like
and
dairy products like
these things.
cheese, milk, all those sorts of things. Well, that's a good question because then we need to consider the amount of the impact meat products do and compare that to dairy products. Well, they're both made from the meat industry. They're both made by the same animals, which would be cows, and cows always do have a detrimental impact on the environment, especially at the rate that we are having that. But no, I wouldn't. I would not know because if if you're excluding meat from your diet, but you are eating cheese, it sounds almost to me like a transition, like you're in the midst of a transition from a more vegan based from a meat eater diet to a more vegan based one. Right.
Um, if no one else has any more questions, that will be all for Liam's presentation. Thank you for it. And now we will move on to Luke's presentation on the effects of climate change and the devastating carbon emissions. So,
All right, yeah. Um, yep. So, hey everyone. I'm Luke Zhao. I'm a senior here at Diamond Bar High School in California, and I'm one of the co-founders of the Climate Change Task Force. And today I'll be presenting on a number of topics that all fit within the general topic category of effects of climate change. I know Liam just talked about livestock. That's one of them, but I'm going to be going a bit more broad and discussing more, I guess, more widespread ones as well. And I'll also be including a slightly smaller section on the current situation of our carbon emissions and some general trends regarding that as well. So next slide, please. So in our first section here, I'll be discussing the effects of climate change. So as you can see in the picture there, this is an industrial plant releasing tons, like literally tons of greenhouse gases into the air. And so by releasing all of these greenhouse gases, these industrial plants are going to create tons, pun intended, of repercussions for the future of our planet. So we'll look at some of the more important effects here. I should say though, I should forewarn that even though I only discuss a few of the effects that climate change induces, there are way more effects that I haven't talked about or that I won't talk about within this presentation. Some resulting from a chain effect from these effects, and others are just direct consequences of the causes as well. But without further ado, let's get right into it, starting with rising temperatures. And so, yeah, the rising of global temperatures has been fairly, in my opinion, I would say it's pretty apparent. After all, 2020 is on track to be the warmest or the second warmest year on record. And so with the drastic increase in our greenhouse gas emissions, the atmosphere is able to trap a lot more heat inside of our Earth, which can obviously contributes to the increase in global temperatures. And so according to NASA and according to the IPCC, global temperatures will continue to rise for decades. And in fact, the IPCC forecast a 2.5 to 10 degrees Celsius, 10 degree Fahrenheit increase in global temperatures over the next century or so. Now, of course, in any field, there's no absolute. Here, even with rising temperatures, there are both beneficial and harmful impacts. But as temperatures continue to rise, the harmful impacts will greatly tower over, they'll greatly overcome the beneficial impacts. And so if we go to the next slide real quick. So I've included a little video here from NASA. If we can take a look at this 30-second video, we'll see a pretty obvious change in global temperatures from the 20th century to the 21st century. So here you see there's a lot more blue here, overall blue, which refers to more cooler temperatures, more cooler temperature anomalies. Now, as we're approaching the 20th century, mid 20th century, late 20th century, you're seeing a little bit more yellow, more red. And then, just wait a little bit, as we go into the 21st century, now there's a lot more red, a lot more orange. And so this temperature anomaly is so apparent from just this video here. And then one last thing before you go on to the next effect, if you want to go to the previous slide, I included it there as well. With the increase in temperature and the warming of the Earth's climate, coupled with the frequent droughts in Africa, so there is a higher dust availability and a higher period of dust uplift. And so this leads to a multitude of issues ranging from reduced air quality to reduced water quality to malnutrition, maybe to even respiratory issues for many of us. And one pretty interesting, and when I was researching this, I actually didn't know this, but one pretty interesting and unexpected effect of this is actually the increased melting of ice. So when dust is being transported via several different atmospheric phenomena, it can be transported onto ice, and it makes the ice darker. And as you know, darker things tend to absorb more sunlight or more light in general. And so as they absorb more sunlight, they absorb more heat. And as a result of absorbing more heat, they actually cause the ice to melt faster. So if we can go on to the next section, about 2 slides over. So next slide. And so this melting of ice is actually what our the next effect that I'm going to be discussing. So with the rising of global temperatures and this phenomena of dust transportation, there's an increased rate of the melting of ice as well. So as you can see from the bottom 3 graphs over there, those 3 graphs are all from NASA's website. There's been an overall decrease in the land mass and land area. So in order from left to right, there's the decrease in Antarctic mass, the decrease in the Greenlandic mass, and the overall decrease in Arctic mass of ice sheets as well. Actually, the Arctic one is land area, ice area. And so for the Antarctic ice sheets, there's been an overall decrease of around 148 billion metric tons per year. And for the Greenlandic ice sheets, there's been an overall Greenlandic, there's been an overall decrease of around 279 billion metric tons per year. For the Arctic ice sheets, there's been an overall 13.1% decrease in ice sheet area per decade. And so even in 2012, which is actually pretty recently, it's not that far off, the Arctic ice sheet area was at its lowest point. And so in all of these scenarios, the loss of mass and area of ice is just extremely impactful, extremely substantial. And in fact, one significant impact of all of this was the dramatic increase in sea levels that Dr. Fenty had just talked about, which if you go to the next slide, you see that as more ice melts, sea levels rise as well. But the melting of ice isn't the only effect or the only factor that plays into the rising sea levels as well. As Dr. Fenty just said, there are other factors as well, which one of which is the expansion of seawater as the temperatures rise. And so from 1880 to our present day, the sea level has risen approximately a total of around 8 inches or so. But that's the slightly okay part. The worst part is over the next 80 years or so until 2100, the sea level is expected to rise a total of approximately 1 to 8 feet. That's a huge amount. And the growth rate, the projected growth rate, as you can see in that bottom left graph over there, is projected to be around 3.3 millimeters per year. So sum that up over the course of 80 years or so, and you can get maybe 1 to 8 feet, depending on variation and stuff like that. And so with higher sea levels, there's going to be even more storm surges, more high tides, more tsunamis, more natural disasters regarding water and bodies of water, which would ultimately lead to more flooding, like the floods in China and in Japan as well. And so this increase in flooding is ultimately extremely devastating to civilization and society as we know it. Yeah, let's go to the next slide. So kind of related to the rising of sea levels is the amount of precipitation that falls. So in the US, the average precipitation has increased by around 5% ever since the 1900s or so. A number which I guess when compared to other effects is slightly on the lower end. this 5% does account for how some areas have had a large increase while other areas have had like a minimal increase or maybe even a decreased amount of precipitation. And it also accounts for several great droughts that have happened. For instance, the great droughts in like say 1930 or 1950 or so. Um, but you could argue that this relatively small effect on precipitation is just due to natural causes. So even though this is not the most notable effect on precipitation due to climate change, it's still good to keep an eye out for these small effects as well, because we've got to be on the lookout for anything that could result in damage to the environment. Let's go to the next slide. So with all of these effects, there's going to be tons of even more effects on the strength and severity of natural disasters as we know it. So for droughts and heat waves, the frequency and intensity of all of these long-term disasters will be drastically increased. In fact, one of the things I looked over was extreme heat days. So before, extreme heat days would only occur about once every 20 years or so. If we continue in our track, in our current track of I guess ignorance against environmentalism, extreme heat days could become as frequent as once per every 2 to 3 years or so, or even more frequent than that, which is basically a 10 times in frequency. So some pretty clear examples of intense heat waves are the one that happened in Australia in 2019, and even more recently, the one that hit Southern California or so in early September of 2020. It basically caused temperatures to rise to 121 degrees Fahrenheit, or in Celsius, that's 49 degrees Celsius. It was pretty insane. So like with heat waves and droughts, more intense and more frequent hurricanes are going to be expected as well, resulting in even more Category 4 and 5 hurricanes that form due to these warmer waters. So if you haven't heard, Cyclone Amphan, which had recently hit eastern India and Bangladesh in May of 2020, was the most powerful cyclone to strike this region and actually caused billions in dollars of damages as well. And so with more hurricanes, there's going to be more flooding, and with more flooding, even more damage to man-made structures and even more damage to civilization as we hold it now. So being able to combat this change in climate is absolutely crucial to our maintenance and our standing as society. Let's go to the next slide. Now, there are a lot of different effects of climate change, not just on the environment, but also on our livelihood as a society and civilization. So in agriculture specifically, climate change has actually caused frost-free seasons to increase in length and duration, and also the growing seasons as well. So if you take a look at the two graphs down there below, so these two graphs basically just show the region of frost-free areas. So I don't know if you can tell, but there's a light green area and a dark green area. So the light green area in both of them was the frost-free area in 1950, actually from 1950 to 1952. The dark green area represents the added area that we've measured basically between 2009 and 2011. So the dark green area is the added area, but it also includes all of the light green area as well. And so the very observation that there is an increase in the area of frost-free seasons, and actually this area is not significant either, because I mean, while it might look small, the area itself is actually huge and significant. But this increase in area is definitely a sign or a warning for how much climate change could devastate not just the environment, but also human civilization as it is. So let's go to the next slide. And so with all of these changes in our surroundings and the environment, there's bound to be health complications that arise from these. So if you look on the chart on the left, which is actually taken from the CDC, if you can read the text in it, I know it's a bit small, but it describes many of the health effects that a change in the weather or climate can have on any one individual. So these range from serious injuries and mental health issues resulting from severe weather shifts to respiratory issues and development of asthma resulting from air pollution, to even malnutrition or the development of cholera or other waterborne diseases as a result of water quality impacts. And so there are even more macroscopic and more impactful ones as well. So total environmental degradation, which is actually entirely possible given our current progression, can result in the forced migration of certain groups to other places, which can result in huge political hardships or conflicts and stuff like that. And when trying to deal with all of these health issues, there can be like huge medical costs as well. So in resolving this current climate crisis and coming up with a solution to many of these issues, there's always a chance that we can bring aid to someone who cannot afford to find treatment. Let's go to the next slide. So in the US, this is specifically in the US, there are also several issues that can arise from a changing climate. And even though I'm only discussing the US here, the same consequences and the same principles and ideas I'm bringing up here can be applied to many other nations in the world as well, and other cities as well, depending on their geographical location, economy, and several other factors. So in the Northeast states, I'm talking Maine, New York, New Jersey, that area. Sea level rise, sea level rise, erosion, inundation. There's been an increase in wildfire outbreaks. There's an increase in ocean acidity as well. Tree diseases. All of these things are causing huge amounts of havoc on the economy and on the infrastructure. Um, in the Northwest, there's a bunch of erosion, even more inundation. There's heavy downpours and the rising of the sea levels. That's having an effect on the economy as well, especially the economy that's dependent on fish, on the ocean. In the Southeast, the rising of the sea is absolutely the biggest issue to the economy there. The Southeast has places like Louisiana, whose culinary economy is dependent on the seafood there. Cajun food is absolutely dependent on seafood as well. So the rising of the sea has been an absolute issue for the region's economy and environment. Let's go to the next slide. In the Midwest, there's extreme heating, there's strong downpours of rain and flooding. All of these will affect the infrastructure and the health and quality of the region. That picture there you see on the slide there is a picture of the Dust Bowl, which, I mean, it happened quite a while back, but it's just an example of what might happen to the Midwest if things continue along the track that they're going at. And finally, in the Southwest, where I am from and where Edmond is from, there's been more intense heat waves, more frequent droughts, insect outbreaks have been ruining crops, increasing incidents of wildfires. There's been like really heavy or really harsh wildfire seasons over here. There's been declining water supplies, reduced agricultural yields, flooding. All of these issues are causing even more issues. So there's like a chain effect developing that's going to lead to even bigger and bigger problems. And so in just one nation, if climate change can cause so many different issues, imagine how many issues it could cause if it became an even bigger problem, and if we also considered its effect on multiple countries as well. Let's go to the next slide. All right, and so there's a couple other general environmental changes as well. So here I'm talking a bit more about effects on other animals, for instance, and ecosystems as well. So climate change has also greatly affected many animals. And so one prominent example is shown here in this picture. It's a polar bear being stranded on ice. And so with this increasing melting of ice, polar bears are actually being stranded on smaller pieces of ice, and they're being isolated and stuff like that. So other animals like the green sea turtles, the monarch butterflies, leopards, stuff like that, they're also being heavily affected by climate change as well. Now, why they're being affected is also a result of climate change. So flooding and natural disasters and wildfires and stuff like that, they're also resulting in substantial habitat loss. For instance, like burning a wildfire that can burn a forest in like a day or two can isolate many species or many different animals like that. Now, these natural disasters can also force these animals to migrate elsewhere. So let's say if you have like a leopard that has to leave a place and go to an area with even more food and stuff like that, that can be considered an invasive species. Now they're disrupting the ecosystem in another separate place. And that's going to lead to even bigger complications down the road. And last but definitely not least, the increased acidity of water and rain, which is caused mainly by the industrial release of toxic compounds into the atmosphere, is also extremely harmful to wildlife, especially fish and coral reefs. Let's go to the next slide. So as you can see, there are a lot of effects that climate change can have both on our environment and on us as a civilization as well. But what is causing the climate to change? Well, in many cases, actually, the climate is changing as a result of many different factors. There's no single factor that you can that isolate, that you can say was the sole cause of everything that climate change has caused. But arguably, one of the most important factors is our excessive emission of carbon-based compounds, especially carbon dioxide, as well as other toxic compounds as well. Let's go to the next slide. So there are a number of notable fossil fuels. Many of these Dr. Fenty had said in his presentation. Um, of these, the most famous ones are carbon dioxide and methane. Carbon dioxide actually results from, of course, the burning of fossil fuels, deforestation, land clearing. Methane itself originates from agricultural activities and the burning of biomass. Other compounds include nitrous oxide, N2O, which is used as a fertilizer in many different agricultural activities, as well as fluorinated gases. Now, of course, we just talked about chlorofluorocarbons, one of the most famous types of fluorinated gases, which are actually known to react with ozone in a kind of chain reaction. That's why it's able to stay in the atmosphere for so long. Next slide. So while I was making my slides and researching this, I didn't actually know that many of my charts would actually be used in Dr. Fenty's presentation. So a bit interesting. But anyway, knowing this, we now take a look at several different charts, which are from the EPA. And yeah, so on the left here, I don't know if you can see that, but that's basically those two charts on the bottom left are the same ones that Dr. Fenty had on his slides. Basically, carbon dioxide accounts for a summed total of basically 76% of our carbon emissions, followed by methane at 16%, nitrous oxide at 6%, and fluorinated gases at 2%. In the second graph, it's not really a surprise, but basically electricity and heat production, the agricultural sector and the industrial sector are all the highest producers, the highest economic sectors that are producing the most greenhouse gas emissions. The top two graphs, if you can maybe see them, basically show the top emitters or the top producers of greenhouse gases. And so they include China, the United States, the European Union, India, the Russian Federation, Japan, among others. And if you look at the graph on there, you'll see that actually, I don't know if you can tell, but China is by far the highest producer of greenhouse gases. Um, but it is important to note that on September 22nd, 2020, President Xi Jinping did announce before the UN General Assembly that China will, quote, aim to achieve carbon neutrality before 2060, end quote, which could mean that China is now, quote unquote, officially in the fight against climate change. And then very last thing at the bottom, there is a graph that shows the number of metric tons of carbon emitted from the 1900s to our present day. So if you look at the graph, it looks very exponential. And so this exponentiality definitely shows that in our present day, we are producing way too many more greenhouses and carbon-based compounds into the environment than is acceptable. So last slide, actually second to last slide, I want to leave off my presentation with this quote by Barack Obama, former President Barack Obama, who states, quote, "We are the first generation to feel the effect of climate change and the last generation who can do something about it," end quote. So just a little food for thought as we move forward into how we can potentially do something about climate change. Next slide. And so with that being said, I want to thank you guys for coming to my presentation and fight on for the climate. I'll take any questions now.
All right, so yeah, thank you, Luke, for your presentation. I actually have a question for you about your presentation. So basically, my question is, so you mentioned a lot of the effects of climate change and how it negatively harms humans and animals around the world. So what do you think is do you think that policy in the federal, state, or local governments, is that the correct way to go about changing what we're doing right now?
In my opinion, policy having the correct policy is most definitely crucial to being able to fix all of the problems that have caused climate change. After all, you have to be allowed to do what you need to do in order to fix the climate. So having the correct policy is the first, in my opinion, is the first step and the most important step to being able to mitigate all of these effects of climate change.
Okay, thank you. If does anyone else have any other questions to Luke about his presentation? If so, make sure to unmute or raise your hand. Okay, yeah.
If not, if there are no more questions, then we'll go on to our next presentation by Edmond Yu. He's going to be talking about paying it forward doubly, how we can connect the climate change curriculum to community service. So hold on.
Okay, so yeah, so this will be our last formal presentation or lecture about climate change that I will be discussing with you guys. So good afternoon, everyone. My name is Edmund, and I am currently a junior attending Diamond Bar High School and also one of the leaders of the Climate Change Task Force. So throughout this conference, our amazing speakers have already taught you about the impacts of rising sea levels, causes and effects of climate change, and finally, the current state of global carbon emissions. So in this last presentation, I will be shifting our focus from pure scientific data surrounding global warming to what you can do as an individual who desires a cleaner society. Thus, our final topic is Pay It Forward, combining climate change curriculum with community service. Next slide, please. Before divulging upon the community service aspect of spreading climate change awareness, an essential question must be answered. Why is educating people regarding climate change even important? So there are two parts to answering this question. The first is lack of action even among those who believe climate change is real. And the second is the political polarity generated by the topic of climate change. So let's start discussing these 2 points in our next slide. For many Americans, climate change still seems more or less theoretical. Most people say that climate change is real, but don't understand the significance of its impacts around the world. And this is because when you are living comfortably in your home where climate change has a minimal effect on your life, you don't care enough about it to change. Now, I believe that the recent wildfires in California that burned throughout September was a major wake-up call that illustrates the reality of global warming. In fact, two of these wildfires were recorded as being the two worst wildfires in history. When you can see red and orange skies caused by the pollution from these fires through your window, you begin to understand that climate change is indeed a real issue that is affecting the lives of humans today. But how many more of these wake-up calls do we need? Remember, these Californian wildfires can destroy someone's life. A person's entire world can be flipped upside down at the blink of an eye due to the burning of their homes and belongings. The main point here to take away is that other people's lives should not be put in jeopardy because we don't care enough about climate change to change our lifestyles. Additionally, the political divisiveness that climate change creates in the United States clearly shows the necessity of more climate change education. In my opinion, the application of politics in climate change discussions is highly underemphasized. Next slide. From a survey conducted in 2019, although 90% of Democrats believe that the federal government is doing too little to reduce the effects of climate change, only 39% of Republicans agreed. In order to truly initiate environmental reform, policies addressing climate change must be implemented at the federal, state, and local levels. When over half of a major political party in the United States believes that the federal government should refrain from passing more climate change policies, reaching our goal of environmental reformation is extremely unlikely. Instead, we need to lessen America's political polarity through uniting citizens under the common consensus that climate change is real and that we must do something about it. Now that we have addressed the necessity of climate change education, I will elaborate on the topic of creating community service opportunities through teaching a climate change curriculum. Next slide. The first step into this process is the establishment of environmental clubs and organizations at all levels. Organizations of climate activists can be formed in middle schools, high schools, colleges, and of course, as a real nonprofit as well. The purpose of these influential organizations is to form a dedicated community of people who truly care about the environment, no matter how big that community is. At first, focus on attracting as many local members to your club as you can. This base circle sets a firm foundation for your organization as you can start holding activities and setting goals for how your specific organization wants to deal with climate change. As time goes on, leaders might decide to create new chapters of their organization in other cities, states, and even countries. Of course, this form of global expansion is always beneficial in spreading climate change awareness to even greater masses. However, it is important to note that no matter how big your organization is, you are still making a difference in our unified goal of combating global warming. After founding an organization that focuses on the need for a cleaner environment, the various activities held and promoted by the organization determine its successfulness in making a positive impact for the Earth. An initial objective that should be targeted by leaders in an environmental club is to create a curriculum that explains the phenomenon of climate change and explores the basic scientific explanation behind why climate change exists. This curriculum can be used to introduce new members and even complete strangers to the complex topic of global warming by identifying it as a problem that must be dealt with. Designing and presenting a curriculum that evokes emotion into the audience can help convince those who are new to the topic of climate change to join the fight against it. Next slide. In fact, the Climate Change Task Force has already created a brief curriculum on the basics of climate change that can be accessed by clicking on the link bioagents.org/ccc. This short slideshow discusses specific topics such as the greenhouse effect, rise in temperature, heat waves, hunger, and flooding that illustrates the causes and effects of global warming. Returning to the previous slide on goals and activities of climate change organizations, another key aspect of expanding environmental messages is to generate discussion among individuals located around the world. Our Zoom meeting today is labeled as the World Youth Conference because it is meant to encourage the expression of opinions and ideas from the general audience and members of our organization other than just our speakers. When hearing multiple perspectives regarding the harms of climate change, you gain more insight on its undeniable consequences in ways you could have never considered. This is due to the fact that climate change is known to disproportionately affect people living in different countries. Understanding the importance of talking to others about their environmental concerns, along with emphasizing your own, can stimulate cooperation and unify the members of a climate change organization. The concluding category I've included into the goals and activities of an organization. It sums up the various activities an environmental organization can perform. And this concluding category is real-world projects that involve physically bettering the Earth. For example, there are thousands of tree planting organizations that focus solely on providing volunteer opportunities to people who are willing to spend their day planting trees for the environment. And these real-world projects can inspire regular citizens that have no idea what climate change is. After they participate in one of these activities, they might change their own lifestyles in order to become more environmentally friendly and in order to support the fight against climate change even more. So one of the final topics I want to discuss today is a message's ability to spread exponentially. Words encourage action, and words can certainly have a huge effect on how someone lives their life. If every single one of you here in this Zoom meeting took a point from one of these speeches and expressed it to a friend or family member, this conference's impact in spreading awareness on climate change will be twice as large, if not more. So the next time you have a conversation with someone close to you, It wouldn't hurt to inform them on an interesting fact regarding climate change and encourage them to join the fight against it. Lastly, I will address the question of why young students should create organizations, hold activities, and oppose the effects of global warming. For many, the opportunity to earn volunteer hours is an amazing incentive to engage in community service. Club meetings and conferences formed to spread climate change awareness are excellent ways to serve both your community and environment at the same time. Students, especially, are inclined to join clubs or nonprofit organizations as a way of bulking up their resumes or college applications. Now, I am not saying there is anything wrong with these goals. However, the key thing to note is that volunteer hours should be an incentive only when you first begin your journey of environmental reformation. As motivations increase, your own passion for the earth should be the driving factor that encourages you to educate others. So finally, I want to go to the Climate Change Task Force and our proposals against dealing with climate change. Next slide, please. So strategies to fight climate change. Again, we're paying it forward to our future generations, to everyone on this earth in an attempt to oppose climate change. Couple community service with the message about climate change. This is a key factor that I've already discussed in my previous slides that showcase why it is important to use volunteer hours as, again, an incentive, and then eventually create a passion within the members of an organization truly to oppose climate change. As you help someone you know, ask him or her to help another young person and tell that person about the dangers of climate change. Again, we have designed a climate change curriculum. If you would like to, you can use it to spread knowledge, to spread more education to a growing population about the dangers of climate change and how to deal with it. Community service can be as easy as tutoring a child for free. Remember, our message about the exponential spread of a message. Remember, after teaching one person about climate change, they can go on to spread that message to many more. And community service helps us to unite people together and improve our society. And now we can teach people about climate change at the same time, which benefits all of humanity. Do not be intimidated by the number of children and youth that we have to reach. Remember, again, this is a collective process. We are working towards that goal of environmental reformation every single day. No matter how big that goal may seem right now, we are still on our way working toward it every single month, every single week, and every single day of our lives. We can create a chain reaction if we keep paying it forward, resulting in an exponential growth in the awareness of the dangers of climate change among children and youth. So this picture shows how a message can really spread exponentially. Remember, we start off as one. We tell two other people, and the growth is exponential. They can tell so many people, whereas eventually we'll reach so many people that the climate change message will be universal. However, simply spreading the message about climate change in the United States, Europe, and Africa is not enough. Let's go on to a previous graph presented by Luke about the projections of carbon emissions. You can clearly see that China is the growing country that has increased their carbon emissions in the recent decades. And other countries, some of their carbon emissions are even falling off. Let's go to the next slide. See, you can see right here, China ranks one for the most amount of emissions in 2017 with 27.2% of global emissions. The United States, India, Russia, and Japan follow it. And here is the projections of carbon emissions explained even further. The US, EU, Russia, and Japan carbon emissions are either stable or declining. The countries that will contribute the most to future increase in carbon emissions are China and India. And this is largely due to their large populations, along with how they are developing as a country and going through the demographic transition. We should target youth in China in spreading the message about climate change. There has been no climate movement in China so far, or at least very few climate movements from those Chinese citizens. However, again, President Xi Jinping announced on September 22nd, 2020, at the UN General Assembly that China will aim to achieve carbon neutrality before 2060. This means that China is now officially in the fight against climate change. And this is also a perfect time for organizations such as the Climate Change Task Force and anyone you might create to begin spreading the message about climate change in China. So China has a consumer-driven economy. And why is this important? It's because all of these Chinese children and youth will eventually become adult consumers who wield tremendous power in influencing the direction of their economy. Their beliefs about climate change will matter in their purchasing decisions, and what they purchase, like Luke said, can affect how climate change impacts the rest of the world. So how do we target Chinese children and youth? The Chinese still currently adulate to Western culture. Chinese children still want to learn English, French, German, etc. And these Chinese children still want to interact with people from the West. So we suggest offering free tutoring in English and other European languages to these Chinese children. We also suggest becoming email pen pals and friends with Chinese children. And this allows us to spread the message about climate change in China. Again, remember, China is the most important country in relation to this climate change direction we are trying to go toward. By targeting children in China, we will change how their country views global carbon emissions and how their country will react to the climate change problem. The Climate Change Task Force can help organize free tutoring sessions for kids in China. And we can also help find pen pals in China as well, email pen pals in China as well. There are many Chinese kids in China, but don't forget that the power of exponential growth and chain reaction can certainly help us to spread the climate change message to as many people as possible. After you spread the message about climate change to each child or youth in China, tell him or her to pass on the message to another friend in China or to anyone they know. So that is it for for my presentation today about how community service relates to the climate change curriculum. Thank you for listening. And yeah, now I will be accepting any questions you might have about the issue.
I think I have two questions. So the first one, when we're talking about the expansion of this curriculum, I know that there's some countries, some constitutions of a couple of countries actually forbid a freedom of speech for people. I know that the Philippines are like one example, and Indonesia is becoming something close to it. How many countries actually have this system where people can't actually speak to the government of their country about climate change?
Okay, so that is a good question. I actually don't know the exact amount of countries that have this freedom of speech where we are allowed to express climate change messages to their government, but I would like to really answer your question in a more direct and straightforward way. Like even in those countries that don't permit freedom of speech and don't like go by those rules that our American citizens have or citizens in other countries, we still want to try to convince their government in many ways through the United Nations, through other huge organizations that are global, in order to convince their government and those in charge and those who have political power in those countries in order to address climate change. And I feel like China is a pretty good example of this because the president of China has really like went out and went forward and said that they will be trying to become carbon neutral. So if China can do it, then other countries can for sure follow their path, follow their footsteps in recognizing the problem of global warming and trying to fix it through the education of their citizens.
Yeah, and I have a second question that I don't think that's quite. I don't know, I might be wrong. It's about Indonesia specifically. Like, I think I don't know how much you know about this, but in the last days, there are big brutal protests in Indonesia about the new law that is called omnibus law, and it's like a really corruptive law where a lot of trees are going to, in non-colonized territories, are going to be cut down for like a coal mining. I just want to ask if you or anyone here knows something about omnibus law, how dangerous it is for the citizens of Indonesia, and the consequences can like affect us all, in fact.
Yeah, I think I read an article on that, but I am not that educated about that topic in particular. If any other speaker can speak up and maybe address that question, that would be great. But just my personal thoughts on it. Of course, this Indonesian problem of cutting down trees is horrible for not just the Indonesian citizens, as you pointed out, but the rest of the world. Remember, like these impacts that cutting down trees can have, no matter where that forest is, or no matter where that those trees are located, by cutting down trees, we are contributing to the global problem of climate change because less oxygen is produced and less carbon dioxide is taken in by those primary producers of those ecosystems. So yeah, I just want to emphasize the true globalness of this problem of climate change through your question. And even though I can't really provide an exact explanation of what that Indonesian law is, I just wanted to point that out for you. So Daniel has a question in chat. I think it is a great idea to start climate change related clubs in each community. And if all communities could do something, the impact would be great. Probably next time you could share some ideas about how to set up this kind of club. Okay, yeah, that is, thank you for that suggestion. Remember, this is a World Youth Conference, so we are trying to, take suggestion and take feedback from every member in this Zoom meeting. And yeah, I will for sure try to make a presentation about like the specifics on setting a school club or a nonprofit organization that deals with climate change and what the purpose of that organization is. So yeah, other than that, if no one else has questions, I will leave you guys off with a closing speech. So, okay, guys, thank you to all of you for attending the World Youth Conference on Climate Change and making this a memorable experience for all of us. And of course, again, thank you to Dr. Ian Fenty as well for making time out of his busy schedule to educate us on the topic of rising sea levels through the lenses of a true expert. Without him, this conference would not have been possible. I really hope you all learned a tremendous amount from this conference and will use your knowledge to educate others. As the Climate Change Task Force, we are planning on holding more conferences and other educational opportunities in the future to continue our spread of climate change awareness around the world. If you would like updates on our future plans, or you simply have a question regarding what we do as an organization, please feel free to contact us via Twitter at ClimateChangeTF or through the email climatechangetaskforce@gmail.com. Other than that, there's not much else to say, so I would like to leave you guys off on this note. Climate change is a growing threat to not just your individual state or country, but the entire Earth. I urge you guys to join us in our global movement to unify the world's climate activists and instill hope within the hearts of many. Thank you.